So the goal here is to find the integral. We would like to find the integral of x squared times the cosine of 1/8 of x with respect to x. So the way we will solve this, we will use we'll use integration by parts. And in integration by parts, we have the integral of u dv is equal to u times v minus the integral of v du. So this is the formula that we need to use. And in this case, we have to choose our u and v. And in many cases, or in most cases, we select u to be something that vanishes when you find its derivative. So we can set this to be our u and this to be our dv. So our u is equal to x squared and our dv is equal to cosine of 1/8 x dx. So we take the derivative. So what's the derivative of this? This is du is equal to 2x dx. So now what is v? V is the integral of cosine of 1/8 x dx. The integral of this, you find it by using u substitution. And so the answer to this is 8 sine 1/8 of x. Okay. So if you, the way you can see that is the integral of cosine 1/8 of x with respect to x. You let your u to be 1/8 of x. So your du is equal to 1/8 dx, which means dx is 8 du. So when you replace, you end up with the integral of cosine u, and then dx is 8 du. And so that gives you 8 times the integral of cosine u with respect to u, and that is 8 sine u. Your u is 1/8 x. So that's how you do that one. So that explains this one. So remember now, we need to use our formula. So the integral of x squared cosine 1/8 x with respect to x is equal to uv. So u is this, so that's x squared times v. V is 8 sine of 1/8 x minus the integral of v. V is 8 sine 1/8 x times du, which is 2x dx. Now, so we can continue. So that gives us x squared, 8x squared sine 1/8 x minus 16 times the integral of x sine 1/8 x with respect to x. So again, so this time you set this to be your u and set this to be your dv. Okay, so once you do that, you say your u is equal to x, so your dx is so your du is equal to dx, right? And your dv is equal to the integral so your dv is equal to sine of 1/8 x dx. And based on that, you find the integral of both sides, okay? So your v is equal, so the antiderivative of sine is negative cosine, but then you're going to do the same thing you did here. So the answer there is -8 cosine 1/8 x. So our answer now, we are not even done. So it's 8x squared sine 1/8 x minus 16 now times, so uv, so u is x times v, which is -8 cosine 1/8 x minus the integral of v, so that's -8, so we can make this plus because v is this, so 8 cosine 1/8 x du is dx. Okay, so now going to get rid of this space so that at least I can show you everything here in one page without moving to another page. Okay, so the integral now is equal to 8x squared sine 1/8 x. Now, so you distribute the -16 to this. So you multiply -16 by -8. So -16, so 16 times 8, you end up with 128. So that's plus 128x cosine 1/8 x. You still distribute this to this. So you get minus 128 times the integral of cosine 1/8 x with respect to x. And this gives us 8x squared sine 1/8 x plus 128x cosine 1/8 x minus, so you look for the antiderivative of cosine 1/8. We already know that from previously. So this is 128 times 8 sine 1/8 x and then plus c. So your final answer is that. I don't need to write it again, but that is what it is. Just need to multiply these two numbers, and that's it. So the integral of this particular expression is this. So the antiderivative, that is. And we have to add the constant of integration at the end. So I didn't keep on adding those as I integrated, because they will just be constants, constants, constants. And at the end, when you sum all the constants, you get a constant. So there was no use. And that is how you do U substitution. Not U substitution, but integration by parts, where there are multiple integration by parts in a problem. Thank you.